Every day, Netflix builds your specific viewing habits into a recommended queue. Spotify predicts the exact track you want to hear next. Your phone unlocks in milliseconds using the biometrics of your face, and Google Maps reroutes you around traffic before you even see brake lights. For decades, the software running our machines was governed by strict linear logic. Programmers wrote absolute rules. If A happens, do B. The machine followed those human-authored rules without deviation. This traditional architecture breaks down the moment it encounters ambiguity. A rigid decision tree possesses zero capacity to adapt, judge, or creatively solve a problem if it falls outside its hard-coded parameters. The algorithms managing your streaming queues, secure logins, and daily commutes no longer rely on those static, human-written rules. Our entire digital infrastructure has quietly moved away from linear programming. If we continue to view our devices as simple tools executing basic commands, we will fail to grasp the scale of the disruption currently altering society. To solve the limitations of rigid code, engineers developed neural networks. A neural network is a computing architecture modeled roughly on the interconnected neuron structure of a biological brain. We stopped giving computers rules and started giving them raw data. We feed these networks millions of books, medical records, and images, allowing the system to process information through thousands of simultaneous pathways. As the data flows through, the network begins to recognize complex patterns entirely on its own. Without human guidance, it learns to infer context, identify relationships, and organize chaos into structure. Neural networks develop their own internal logic to navigate new information, bypassing the constraints of static human instructions. This transition from rigid rules to autonomous pattern recognition is the specific technological change driving the way we build and use software today. The human visual system has strict biological limits. When we look at the progression of a disease at a cellular level, the complex, subtle patterns of mutation often hide in plain sight, missed by the human eye. Google developed an AI system specifically to analyze mammogram scans. By processing vast amounts of imaging data, the AI successfully detects breast cancer with higher accuracy, fewer misdiagnoses, and fewer false positives than board-certified human radiologists. That same pattern recognition capability was applied to biology. DeepMind's AlphaFold instantly solved a protein folding problem that had stumped scientists for 50 years. AlphaFold is an AI system developed by Google's DeepMind that predicts the 3D structure of proteins from their one-dimensional amino acid sequences. The same scalable intelligence that decodes biological proteins can be deployed to a tablet in a remote village. A student sitting thousands of miles from a traditional school can now access a highly adaptive AI tutor that tracks their learning style and reasons through math problems with them in real time. We can now deploy world-class reasoning to anyone with an internet connection. This scales our ability to clear humanity's oldest bottlenecks in health, scientific discovery, and education. Because neural networks learn exclusively by ingesting the data generated by humans, they inherit our historical flaws. They absorb societal biases buried in the text and images we feed them. This results in algorithmic bias with immediate consequences. We are already seeing hiring software that discriminates against female applicants and criminal justice algorithms that demonstrate severe racial prejudice when predicting repeat offenses. This capacity to synthesize human patterns also enables the creation of deepfakes. Deepfakes are highly realistic, synthetic media, where a person in an existing video is seamlessly replaced with someone else's likeness using artificial neural networks. This allows for the weaponization of misinformation, generating convincing videos of politicians saying things they never said. In some regions, pattern recognition is actively deployed as a tool of state control. Facial recognition networks track citizens' movements, monitor dissidents, and enforce social compliance with automated precision. Military powers are currently pouring resources into autonomous weapon systems. Drones and missile defenses are being integrated with AI to process battlefield data and make lethal targeting decisions in milliseconds, far faster than any human operator. Without human overrides, these autonomous systems create a critical ethical crisis and a threat to global security. Right now, we are surrounded by narrow AI. Narrow AI is a type of artificial intelligence designed to perform one highly specific task, like language translation or image generation, without possessing generalized human cognitive abilities. This chart shows the projected economic displacement driven by these specialized systems. As AI capabilities spike, McKinsey estimates that by 2030, up to 800 million white-collar, knowledge worker jobs globally could be automated out of existence. While AI will displace traditional roles, it will also mandate entirely new categories of work, like prompt engineering and human-AI collaboration. Managing this transition requires immediate policy support and societal retraining programs to address shifting economic needs. And the capabilities are accelerating toward general AI. General AI is a theoretical system that can understand, learn, and apply knowledge across any domain at a level equal to or greater than a human being. We are engineering a new kind of mind. The choices we make now regarding regulation and ethics will determine if this technology improves the human condition or leads to our obsolescence.